Hey guys, Mr. Bernard here. So today we're going to get started with some more factoring. Our expression that we have here is 3a cubed plus 12a squared plus a plus 4. And so we don't have a method in order to do this because we have that 3a cubed. So that's what today is going to be. We're going to be using a new method, and this is called factor by grouping. So with this method, we're going to start things off. We're going to split this expression in half. We're just going to draw a little line down the middle. And we're going to just focus on the left-hand side and the right-hand side independently from each other. On this left-hand side, let's take the GCF out of those two terms. So GCF between 3a cubed and 12a squared, we're going to pull out a 3a squared. And if we divide both of those terms, we're going to get a plus 4, dividing both of those terms by 3a squared. And now on the right-hand side, we want to get another a plus 4, which we already do have, but we want to pull out a GCF from it first. And the GCF between a and 4 is going to be 1. So we're going to write plus 1 because they are co-prime to each other. And if we divided both of those by 1, we'd get a plus 4. So these match each other, which is good. And now we have 3a squared. So we want to rewrite this plus 4 plus 1a plus 4. Now we want to pull out another GCF from this, which in this case is going to be the a plus 4. So we get a plus 4 times 3a squared plus 1. And that's our answer. If you want to check this, always double distribute. So the method for this, you're going to draw a little line in between just to split the expression in half, or the equation in half. Then find the GCF on the left-hand side, find the GCF on the right-hand side. Try to get the part inside the parentheses to match each other. And then you can solve from there. So we have another example here. 2x cubed plus 6x squared minus 4x minus 12. So let's draw our line down the middle. Focus on the left-hand side. 2x cubed plus 6x squared. GCF between those is going to be 2x squared. And so in our parentheses, we're going to have an x plus 3. And now we want to get another x plus 3 on the right-hand side. So how could we do that? Well, if we take out negative 4 as our GCF, we'll get x plus 3. So now these match. So let me fix this. And so now we have 2x squared, x plus 3, minus 4, x plus 3. Pull out a GCF from those. We get 2x squared minus 4 times x plus 3. And that's our answer for that. Next one, a little bit more involved. So we have... Actually, before we even get started, let's draw that line down the middle. So we have m squared x squared plus m squared plus b. So what do we have in common here? We have the m squared. So then we're left with x squared plus b. And on the other side, we have negative 2nx squared minus negative 2nb. Sorry, minus 2nb. And so for this one, we can take out the negative 2n. And we're going to be left with x squared minus b. Sorry, x squared plus b. And so we're left with m squared minus 2n. Times x squared plus b. And we get this from, if we rewrite it and we pull out the x squared plus b as the common term. And so our last example that we have here in red, let's draw our line down the middle. 5x cubed plus 7x squared. Well, the only thing that we have in common here is just going to be x squared. So we're going to be left with 5x plus 7, because 5 and 7 are co-prime to each other. Then we have negative 20x minus 28. And so here, we can take out a negative 4, because we want to get that 5x plus 7 in a set of parentheses. And that's the only way how we could get it for this. So negative 20 divided by negative 4, we're going to get 5x plus 7. And now if we rewrite this, we'll get x squared plus, times 5x plus 7 minus 4, 5x plus 7. Now we take out the 5x plus 7 as a GCF. And we have x squared minus 4. But we're not done yet. We still have 5x plus 7. And we want to have x plus 2, x minus 2. And that's the simplest form for this one. If you guys have any questions, feel free to ask. Otherwise, have a fantastic day.